Hello, 30-2s. We are in our first lesson in our new unit called sinusoidal functions. What we're going to do here is look at a very quick video talking about radian measure. Now, by the end of this lesson, I'm hoping that I'll give you two super cool facts that you can go out and ask most people in the world about that they don't know. But it's really interesting because we use these facts every single day of our life. So here we go. First thing I want to talk about before we start talking about sinusoidal functions, this might seem a bit odd, but it's really important for you to understand what we're about to do. It'll help you with the rest of the unit. I'm going to ask you this. I've drawn a Cartesian plane here. Why do the quadrants go counterclockwise? Why do the quadrants go counterclockwise? Well, I'm here to tell you that it's the clock that goes the wrong way, not the quadrants. What? What is he talking about? Well, where does the sun rise? The sun rises in the east and sets in the west. So if I follow the path of the sun, if I'm lying right here at the origin and I follow the path of the sun, what it does is it rises in the east, goes down in the west, goes beneath the horizon, and goes all the way around. The quadrants are following the position of the sun in the sky. That's why they go, what we say, counterclockwise. Why does the clock go the way it does? Because before we had Google and Apple Watches, and we wanted to know what time it was, we would have made a sundial. And remember, a sundial, we would use a shadow. So if the sun was up here, the shadow would be pointing this way. And as the sun changed directions, the clock would go the opposite way, wouldn't it? So that's why a clock goes the way it does. Okay, there's one important fact. Now, why is he talking about this? Because I need you to know a little bit of history. What I need you to know is when we've been looking at trig for the last, I don't know, several years since you've been thinking about trig, we've been thinking of them as right triangles. What I really need you to know, my friends, is that trigonometry is actually about circles. And trigonometry is about figuring out how far away the sun is or a star is up in the sky. That's where trigonometry is really about. It's really about circles. Okay? Now, let's think about what we know about circles. A lot of us, when I say, how far does it take? How many angles does it take to go around a circle? We all know this is 360 degrees. And then I say to you, how do you know that? How do you know there's 360 degrees in a circle? And invariably the answer is, well, someone told me. Okay, well, let's pack this up a bit for a sec. Someone told me. Where does this come from? Where does 360 degrees come from? I need to look at this picture again here. If we go back several millennia to ancient Babylonia, which is in the Middle East, in Iraq right now, present day, they were concerned with trying to answer this question. Here's the sun up in the sky. How far away is the sun? And they're sitting right here. They don't have Google. How did they do this? Well, they answered some pretty big questions. But what we're concerned about here is they thought, and they were pretty darn close. We think that they know they were wrong, but we're talking several thousand years ago. So a lot of this has been lost in the history books, that they thought, of course, the sun went around us. We know that's not true. And they thought it took 360 days, more or less. So guess what? A circle becomes a perfect shape. and 360 must become this very important number. There's 360 degrees. That's it. Honestly, that's where that comes from. Now, the Babylonians used a different number system than we do. We use digits 0 to 9 to make up every number that we can. We're base 10. The Babylonians use digits 0 to 59. They were base 60. Well, start thinking about that. 60 and 360. These are easy numbers for the Babylonians to use. We don't use these numbers like they did, but this is why they said there was 24 hours in a day, because to them, 24 times 15 is 360. These were easy calculations for them. It's not for us. Okay, so who cares? Here's why I care. I tell you this, I am roughly 178 centimeters tall. How tall am I then? What does that mean to you? If I say that to most people in Canada, they have no idea what I'm talking about. But if I said this, I'm 5'10". Everyone goes, oh yeah, I know how tall that guy is. But if I say I'm 178 centimeters tall, most people go, I don't know, is he a giant or is he tiny? I don't know. This is where we are with degrees and radians. This is imperial measure right here. This is metric. We prefer metric because it's easy to convert between units and it's more precise. Why do we still use imperial? Because we've been using it for a long time and it's hard to change. So we still use things today, even though they're not good, because it's not easy to change these things. Here's what I want you to think about today's lesson. Degrees are imperial measure. They're human made. Someone did the best they could. They said, look, it takes 360 degrees for the sun to go around us. That's why we use degrees. It made sense millennia ago, but now we know better. We know the sun doesn't go around us. We know we go around the sun. And we know it's not 360 days, it's 365.24. So what's the counterpart in metric to degrees? It's called radians. And do you notice maybe a little bit of that word there? Radians, radius. It tells me things about my circle. Look at my formula for the circumference of a circle. 2 pi r, depends on the radius. Area, pi r squared, it depends on the radius. It has nothing to do with degrees. Degrees don't help me. So in 30-2, my friends, degrees are dead to us. We do not work with degrees anymore. We only work with radians. They're more scientific. Okay, what's a radian? Well, all a radian is this. It says, going back to the Babylonians, that's why that history at the beginning was so important. Here's my circle again. We're pretty close to a circle. They said this. They were trying to figure out how far away a star was. And they said, listen, I'm never going to be able to calculate that radius there. So they called it a length of 1 astronomical unit, which we still use today. The distance from the Earth to the sun is 1 astronomical unit. Okay, so the circumference of a circle going all the way around is 2 pi r. But they just called the radius 1. So this is 2 times pi times 1. This is 2 pi. Okay, but they said it would take 360 degrees to go around. The circumference is 360 is equal to 2 pi radians. So what do I really need you to know here? I need you to know this, that 360 degrees is this new unit of measurement, 2 pi radians. The distance it takes to go around a circle the circumference of a circle is 2 pi radians, which is approximately 6.28. And we'll keep writing rads. That's our unit for radians. Friends, that's all I need you to know, is that now when we're measuring angles, we're going to measure them in radians. So in the past, you would say to me, if I was measuring this angle, I would say, okay, hey, this angle right here is 45 degrees. All I need you to know, and I don't even need you to know how to convert it, is that this is now this, pi over 4 radians. That's it. I don't even need you to know how to convert the two. I just need you to know that we're working in radians. So please go put your calculator in radian mode. You are in radian mode for all of 30-2. That's it. There's your history lesson. No quiz. Go relax.